In 2024, the most powerful telescope ever built did something extraordinary. It looked at the universe and confirmed physics is broken. The universe is expanding at two different speeds at the same time. This isn't a measurement error, it's not a faulty instrument. Scientists ran the numbers again and again, using the most precise data in human history. The gap only widened, and if both measurements are correct, then the Big Bang model, the very foundation of modern cosmology, is fundamentally, catastrophically wrong. Here's why this matters. In 1929, Edwin Hubble made one of the greatest discoveries in history. The universe is expanding. Simple, elegant, unchallengeable. For 95 years, astronomers refined that measurement using two completely independent methods. Think of it like two detectives solving the same crime from completely different angles, different evidence, different tools, different starting points. The first method stares at the oldest light in existence, the afterglow of the Big Bang itself, 380,000 years after creation. The second method watches real galaxies right now, tonight, moving away from us across the cosmos. Two detectives, two ironclad cases, two completely different answers. The early universe says expansion should be 67 kilometers per second per megaparsec. The modern universe says it's 74. That's a 9% difference. In cosmology, that's not a rounding error, that's a revolution. And in 2024, when James Webb, humanity's most powerful eye in the sky, double-checked the modern measurements with unprecedented precision, the discrepancy didn't shrink. It got worse. This means one of three things. Our understanding of the early universe is wrong, our understanding of the modern universe is wrong, or physics itself behaves differently than we ever imagined. What if the universe is lying to us? Let's go back to the beginning. Not the Big Bang itself, we can't see that. But 380,000 years later, when the universe had cooled enough for light to finally move freely for the first time, that light is still traveling. We can still see it. Scientists call it the cosmic microwave background, the oldest photograph in existence. Those microscopic temperature variations you see, they're the seeds of everything, every galaxy, every star, every atom in your body. All of it grew from those tiny ripples in the early universe. Between 2009 and 2013, the European Space Agency's Planck satellite mapped this ancient light with breathtaking precision. Using Einstein's field equations, scientists then worked forward in time, calculating exactly how fast the universe should be expanding today, based on what the infant cosmos looked like then. The answer, 67.4 kilometers per second per megaparsec. The error margin? Just half a kilometer. This is one of the most precise measurements in the history of science, but, and this is crucial, that calculation assumes the standard cosmological model is correct. It assumes dark energy is a constant force. It assumes dark matter behaves exactly as predicted. It assumes nothing strange happened in the first billion years. It assumes a lot. If that model is even fractionally wrong, the entire prediction unravels. And here's the uncomfortable truth. We built that model on assumptions, beautiful assumptions, mathematically elegant assumptions, but assumptions nonetheless. What if the universe had a growth spurt right after the Big Bang that we never knew about? Now let's come back to the present and look at how we measure expansion directly using the universe as it exists tonight. Astronomers use what they call standard candles, objects with precisely known brightness. The most important, Cepheid variable stars. These stars pulse, brightening and dimming, at a rate that is directly linked to their true luminosity. Measure how bright they appear from Earth, compare to how bright they actually are, and you get exact distance. Cosmic GPS. Then you measure how fast those galaxies are fleeing using redshift, the stretching of light waves as galaxies race away from us. The faster the galaxy, the more stretched the light, the redder it appears. Distance plus velocity gives you the expansion rate. The SH0ES team, led by Nobel Prize laureate Dr. Adam Rees, has been refining this measurement for over a decade. Their latest result, confirmed by JWST in 2024, 73 kilometers per second per megaparsec. That's a 5 sigma discrepancy. In science, 5 sigma is the gold standard for calling something a discovery. It means there is less than a 1 in 3.5 million chance this disagreement is random noise. This isn't a quirk. This isn't going away. This is real. And yet, nobody knows why. Scientists haven't been standing still. Over 1,000 papers have proposed solutions. Here are the 3 most credible, and what each one would mean for our understanding of reality. Solution 1. Early dark energy. What if, for a brief window right after the Big Bang, a cosmic eye blink lasting maybe 1 billion years, there was an extra burst of dark energy that pushed expansion faster than we modeled? A short-lived acceleration that has since faded, leaving no trace we've been able to find. This could reconcile both measurements, but it requires entirely new physics, a form of energy we've never directly observed, behaving in ways our equations don't predict. It solves one mystery by creating another. Solution 2. Einstein was wrong. Not completely, not on small scales. His theory of general relativity passes every test we throw at it on Earth, in our solar system, even in binary pulsar systems. But perhaps at the scale of the entire observable universe, across 93 billion light-years, gravity behaves differently than his equations predict. This would require rewriting the most successful theory in physics history. A theory that predicted black holes, gravitational waves, and GPS satellites, and it might be wrong. Solution 3. We're all making the same mistake. Both measurement methods have hidden systematic errors we haven't detected yet. A contamination in the Cepheid data, a subtle flaw in how we model the early universe, some instrument artifact that slipped past every review. This is the boring answer, and honestly, most scientists hope it's true, because the alternative is rewriting the textbooks, rewriting the Nobel lectures, rewriting everything. But as JWST's 2024 data came in, hope is getting harder to hold on to. But what if the answer is stranger than any of those? Here's a theory that sounds like science fiction, but is taken seriously enough to be published in peer-reviewed journals. What if we live inside a cosmic void? The universe isn't evenly distributed. Matter clumps together in vast filaments and walls, surrounding enormous empty bubbles hundreds of millions of light-years across. If our corner of the cosmos happens to be significantly less dense than average, if we're inside one of those bubbles, then local gravity would be weaker, local expansion would appear faster, and every Cepheid measurement we make would be systematically biased toward a higher number. We'd be taking readings from inside a cosmic funhouse mirror, measuring our local bubble and assuming it represents the whole universe. The 67 from the early universe would be the true global average. The 74 would be our local illusion. The problem, current observations don't show our region being empty enough to explain the full discrepancy, but surveys have only mapped a fraction of the relevant scale. We might simply not be looking far enough. Stop for a second. Hold this thought. We have 2 measurements. Both are precise to 5 decimal places. Both were verified independently by multiple teams. Both were confirmed by the most advanced telescope ever built. Both cannot be simultaneously correct, and yet neither can be wrong. The next 5 years will be the most consequential in cosmology since Einstein. 3 instruments are about to change everything. The Nancy Grace Roman Space Telescope launches in 2027 with a field of view 100 times wider than Hubble, mapping hundreds of millions of galaxies at once. The Euclid satellite is already in space right now, charting the 3-dimensional structure of the universe across 10 billion years of history. The Vera Rubin Observatory will photograph the entire southern sky every 3 nights, accumulating more astronomical data in its first year than all previous telescopes combined. These instruments will measure the Hubble constant with an error bar of less than 1%. They will either find the systematic error hiding in the data or confirm beyond any remaining doubt that standard cosmology is broken. If the tension disappears, we breathe. Standard cosmology survives. The universe makes sense again, but if it gets stronger, we are standing at the edge of a scientific revolution of the kind that happens once a century, the kind that replaces Newton with Einstein, that replaces Einstein with something we can't yet name. Dark energy might not be a constant force, it might be a dynamic field, evolving, changing, pulling the universe apart in ways we haven't modeled. Dark matter might interact with itself in ways we've never detected. The universe might have gone through phases of acceleration that left no footprint except this single, nagging 9% discrepancy. We have a puzzle. Every single piece fits with breathtaking precision, except one. And that one piece is glowing, trembling, insisting that the picture on the box shows something we've never seen, something bigger.
So here is where we stand, right now, in 2025. The universe is expanding at two different speeds. The best telescope humanity has ever built confirmed it. The most precise satellite measurements in history confirmed it. The most decorated cosmologists alive have spent their careers on it and cannot agree. And the answer, when we finally find it, might rewrite everything. I want to hear from you. Seriously. Drop your theory in the comments. Is this a hidden measurement error? New physics? Are we inside a void? Or is there something else entirely, something no paper has proposed yet? Best theory gets pinned. And if you thought this was unsettling, wait until you hear about the dark matter detection crisis. We've built the most sensitive physics detectors ever constructed, buried them miles underground to block all interference, and run them for decades. And they hear nothing. Complete silence. Which means either dark matter isn't what we think it is, or something far stranger is going on. That video drops next week. Subscribe so you don't miss it. Because the universe is hiding something, and we are getting closer to finding out what.